Hello everyone. So I welcome you once again in my lecture. Today we are going to talk about queues. Now this term queue is a very common term and you have come across this terms many times in your day-to-day life. When you go to canteen, you stand in a queue and wait for your turn to get the things. You go to a mall, you go to a shop and then you always see that the queues are there. Now how this term is related to computer science and how it is defined in data structures, that we will see. We will see that how the queues can be implemented. Queue is basically is a data structure that works on the principle of FIFO, FIFO, that stands for first in, first out. That means the item which is inserted first or comes in the queue first will be retrieved first. This is just opposite to the stack, which works on the principle of LIFO, last in, first out. So let's discuss in detail what exactly the queue is and how it can be implemented and used in data structures and in computer science in general. So let's start. So let's look to the basic terminology of this queue. Queue is basically referring to a waiting line that you can see in day-to-day life. You will be uh, observing the queue in front of a bank teller machine, or you can see that the cars are in the queue in front of the toll booth waiting for their turn. So when we talk about the queue is a linear arrangement of elements where the elements are placed one after the another and they have a particular method of their retrieval. It actually means that the item that are to be coming first will be exit first. So you will be as observing this behavior like in the canteen. If you are standing for your turn and if any person comes after you, then he will be getting a chance after you are being served. So that means it works on the principle of FIFO, first in, first out. The one who is coming first in the queue will be served first, or you can say will be coming out of the queue first. This is very opposite to the LIFO, that works on last in, first out. Now here we will see that the entire thing is managed by using the two pointers. We call it as a front and rear, or you can say two variables. So when we worked with the linked list, we call it as a pointer. When we worked with arrays, we call it as a variables. So here we are using two variables, front and rear, that will help us to maintain this principle FIFO, first in, first out. So we have one thing called front, which always take care of the exit, and rear, which always take for care for the enter. That means if you want to add some item, then we need to work at the rear part. We will look to this rear variable. If you want to uh, take some value, or if you want to delete something, then we will look to the front. So this is some basic concept that you need to keep in mind. So you need to keep in mind that the removal can be only done at the front. As I said, that if you want to talk about the exit or deletion or removal, we will be looking to the front. And if you want to add something, then we have to look to the back, that is said to be rear. So we have two things, front and rear. Rear is for addition, front is for deletion. Now this is how the things will work. Always they will point to the extreme ends. Front is, let's say this is our queue, and front is pointing to this 1 and 3 is pointing to this, uh, and the rear is pointing to this 3. So if you want to add an element 4, then you will look to the rear part and you are going to add here, and now rear will point to this element. So rear will always point to the last element and front will always point to the first element. If you want to remove something, then you need to look to the front. So you will be looking to the front, and the front is pointing to whichever element, that element will be removed. So when it comes to deletion, you always look for the front. So you delete the element and then front will point to the next element, and the next element will become the first element. So this is how the things will work. This is just a very basic idea to understand how the queues are working. Then types of queues. So we have different kind of queues are possible and that we are using to implement different applications. We have a linear queue where the elements are arranged sequentially, one after the another, where the first element is pointed to by the first variable or pointer, you can say, and the last is pointed to by the rear. Then we have something called circular. We have certain drawbacks or limitations in the linear queue, and that is overcome by circular queue. So we will discuss in detail that what are the drawbacks. So because of these drawbacks, we are not actually utilizing the queue in full. So in the linear queue, we come to the situation that even when the queue is having a space to occupy more element, but still it will say overflow. Overflow is a condition when there is no possibility to insert more item. So the linear queue is having this drawback, this problem of overflow. That's why we move to the circular queue. Now circular queue is an arrangement where after the last element, after the last position, you are allowed to move to the first position if the first position is vacant. So here you can visualize this is a kind of a format where the after the last element you move to the first element, and this is the optimal utilization of any queue. In the linear queue, this is not the optimal utilization. You are not allowed to use all the spaces optimally or completely, but in the circular queue, it supports the optimal utilization. Then we have double-ended queue, we also call it deck. So in the double-ended queue, we are provided to do the operation at both the end. So when we talk about the general queue, it means that one end will support addition, the other end support deletion, but in the double-ended queue or the deck, you are allowed to perform both operations. So both operations are allowed at uh, both the ends. Then we have another type of queue that is called priority queue, which is very important concept and is uh, used in many applications to improve the running time. Later slides we will see in details about all these kind of queue. So let's have a look about the double-ended queue. So double-ended queue, we call it the deck for the short. It has two points, two endpoints, like in any queue we have. The only difference is that here we are not using the front and rear term. Normally when we talk about the queue, we use the term front and rear. Front is used for deletion, rear is used for insertion. Here we are using left and right, and both pointers or both ends are actually allowed to to enter the element, to insert the element, and to exit the element. Now it all depends on the application. There may be many applications in the real life where you want this kind of provision, so in that case the double-ended queue may be used. And double-ended queue is actually a circular queue, and where after the last element, means after the element n minus 1, n minus 1 refers to the last position of your queue. So after this you are going to the first position, so it's a circular in nature. So to implement this, we are implementing this dequeue with the help of an array, circular array, or a circular linked list. We will see that how it can be possible in our coming slides. We have two variants of double-ended queue. One is called input restricted deck. Now input restricted, as the name suggests, input restricted, it means that input is only possible at one end while the deletion is possible from both the ends. So deletion can be done from both the ends, but insertion will be done only at the one end. Reverse to it, we have called output restricted deck. In this we are allowed to only do deletions at one end, and while the insertion can be done at both the ends. So this is how it can be visualized. This is one deck, or this is one figure which represent a deck. Now you can see here we have two pointers left and right that actually points to the ends, two extreme ends. Now keep in mind the vacant position are always contiguous. You cannot find the vacant position in between. For example, if you see here, these are vacant, and then because this is circular in nature, and then we have this position vacant. You cannot find that this vacant and somewhere in between you can find any position vacant, because when we talk about deck, you are only allowed to perform the operation at the extreme ends. So if you are talking about deck, you are allowed to perform at either at the left side or the right side. So as a result, always these vacant position are contiguous. Now this is another figure that represent the deck. We have these two, this position number 2, 3, 4, 5, 6 are all vacant, and these are all contiguous. Okay, so here you can see, here it is maintaining the left. So left is pointing to this position, index number 3. Right is pointing to index number 7. But because it's circular, there is a scenario that lefts will be moving in such a way, right side and right will go to the left side. So you can see the scenario. The right is now pointing to index number 1, and left is pointing to index number 7. So this is just a very primary introduction about the deck. We will be studying in detail in the coming slides that how actually these can be used in different applications. Then we have something called practicu, as I told you that it is again a very important data structures which are actually used in to implement many applications. Now here priority queues are not working in first in first out way. Normally when we talk about queues, queue basically works on the principle of first in first out. That means the element which is arriving first will be getting a chance to exit first. Here we are assigning the priorities to the element. Whatever the items we are interested to store in the queue, we are assigning the priority, and based on the priority the elements are actually stored. So it all depends on the application that uh, how you are going to assign the priority. Sometimes the more value you will assign some weight to these items, and the more weight may represent the more priority, or the more weight may represent the less priority. It all depends on the scenario. For example, if you are going to uh, make a budget, then lower budget will be a good uh, will set to be a good budget, or a good planning. But if you are going to talk about the profit, the more profit will set to be a good plan. So it all depends on the application that on which context you want to assign these priorities. When there is a situation that two elements are having the same priority, then how it can be treated, then in that case it will show this first come first serve basis. That is first in first out actually basis will be used if the two elements of the same priority is reaching to the queue. So this is just a small description of the priority queue. Let us first understand what exactly the queue is, how it can be implemented, and then we will be dive into detail of the different type of queues. A queue can be used as an ADT. So ADT is something, this is called abstract data type, which actually allows you to perform certain operations. So as we know that it works on the principle of FIFO, it allows some basic operations. So queue is a sequence of data element, and it allows two fundamental operations, that is called NQ and DQ. NQ refers to adding the element, or this is called insert operation. So like in the case of stack, when we talk about insert, we call it push and pop for deletion. This is a technical term that is used with the stack. So when you say push and pop, this is already understood that you are talking about the stack. We don't say push and pop with the queue. But when we say NQ and DQ, this is the term that we are using with the queue for insertion and deletion of the elements. Now you can see here NQ and DQ operations. This is your array. These indexings are here. Now we have already some elements are already shown here in the queue with these indexes. Now if you want to insert a new element, then it is going to be inserted at the last. So this is actually representing to the front, this representing to the rear. So if you want to insert a new element, you need to look to the rear, and then if there is a space in the queue, you are going to insert it there, and your new rear will be the last element. This is how the things are working. Similarly, if you talk about the deletion, you always look to your front, and you go to your front, delete the element, and then update your front. So now front will now point to the next element. So now this element becomes the first element. So whenever you want to delete, you will look to this front, means this element need to be deleted. So this is how the things are working. So this is just an idea that how the things are work. Now we will go and see the formal logic, the formal algorithm, that how the operations can be implemented using any programming language. So this is all about the basics of the queue. Now we will see in our next lecture how the basic operations, the AND, can be implemented using an array and the linked list. Lecture. Thank you very much.